All right, today we are learning about how to create the equation of a circle. This is actually not as bad. It's going to look very similar to other equations you've seen before. So we're just going to dive right into it. Let's go ahead. We have number one. Oh, we have to use that circle. Uh, what do all the points of a circle have in common? Right? It's true for every point about the circle. So they're talking about every point here. What do all these points have in common? Now, as you can see, this is negative 10 away, negative 10, 10, 10, and then any diagonal is 10. As you should have learned prior to this chapter, any line from the center of the circle is the radius. So that means each of these lengths are 10. So what they all have in common is they are all 10. They're all 10. All right. So next, determine all of the points of the circle where x equals 6 for each point where the for the what is the y value. So now we just want to know if x is 6 and we have a what would be the correct y value. Now, actually, I'll scroll up for this. So if this is 6, one way I think that we all know how to do this now is we can do Pythagorean theorem and do 6 squared plus y squared equals 10 squared. And we'll find out that y squared is 8. Well, y squared is 64, which means y is 8. Sorry for my terrible handwriting here. Uh, or you could have noticed it's a 3, 4, 5 triangle. So the values that we could have used if x was 6 is 8 and negative 8, because we could have equally on this triangle gone 8 negative down, and then we still would have gone 10. So in this case, our answer would have been y equals 8 and y equals negative 8. Now we want to find what the y value would be if x is 3. So we just do 3 squared plus y squared equals 10 squared. When we do this, we'll get y squared equals 91, which means y equals plus or minus 9.54. Now, as we move on, one thing that we're going to really want to notice is what is on the other side of our Pythagorean theorem when we're solving this. So that 10 isn't just like a random 10, it is our radius. That is incredibly important. Well, x is our x values left and right, y is our y values up and down. And we will look at what happens when we move this triangle from the exact center in a moment. But before we get to that, let's go to D, where we just want to get a general equation for x and y. So it says Mia picks up a random point on a circle, x and y. Unfortunately, she doesn't know the value of x or y. She wants an equation. And the general equation for this one will be x squared plus y squared equals 10 squared. If we want to make a more general equation than that, we can create x squared plus y squared equals r squared, because that's just our radius squared. And we're going to find out, other points of this that can fully make this equation, but we have a start of our equation, and that is that the circle is just Pythagorean theorem. Now, next, it says, does the equation from part D work for the points 10, comma 0 and 0, comma 10? And what about 8, negative 8, comma negative 6? Uh, Again, if we let x equal 0, or well, x equal 10 and y equal 0, 10 squared would equal 10 squared. If we let x equal 0 and y equal 10, 10 squared equals 10 squared. And we've already solved these two because all we would do is make 64 plus 36 also equals 100. So all the points are the same. So nothing really crazy happens there. I think we understand that. I'm going to let you know right now, I'm not graphing anything. I'll have a conversation. So in this one, they are saying, hey, we have another circle and the center is 0, 0. This is important that we keep mentioning the center is 0, 0, because we're going to be looking at what happens when we're not in the center. Well, we were given a radius of 4. We already figured out that we have x squared plus y squared equals r squared when our radius is at the center. So this equation is just going to be x squared plus y squared equals 16. Next, it says write a general equation with radius r. Well, we've already done that, so I'm not going to do that twice. Well, almost 3 times now. So next, on the coordinate plane, sketch the graph x squared plus y squared equals 36. Can you graph it on a table? I can, but the radius must have a length of 6, and the graph is centered at 0, 0 with a radius of 6. So really all I would do is I go 1, 2, 3, 4, 5, 6. Pick a point here. I would do that upward 1, 2, 3, 4, 5, 6. And yeah, I would keep doing that so I could eventually get a whole circle. And my circle's gonna look terrible no matter what, so I'm just gonna stop there. But you get the idea. That's how we would graph it. Next, describe the graph of a circle with x squared plus y squared equals 0. If I don't have a radius, I don't really have a circle. I have a circle with radius 0, which is pretty much just a dot. It's barely even a dot. It's like non-existent. But just letting you know that, hey, you need that. This is your radius. If you don't have a radius, you don't have a circle. Now, lastly, let's go ahead and get to the last part here. We have a couple of weird things where our center is no longer at 0, 0. And it says, what if the circle is not 0, 0? The diagram shows that we have a center at 3, comma 1, and the radius is 5. So what we're going to do is we're going to write the length of PB, write an expression that represents this length, likewise for AB. How we're going to do that is PB is y minus 1. And how I get that is if I added 1, so we went 1 up here, right? 1 unit up. I want to subtract 1 such that I would go back down. So PB is going to equal y minus 1. Next, I would go to AB. And again, I went 3 units to the right. And I want to see what do I need to do to bring it back. So AB equal x minus 3. Because again, I moved 3 units over, we still x equals 3. 3 minus 3 is 0. I want to know what do I need to do to make it 0. That's pretty much the entire. Now, part B says, hey, if we have a radius of 5, how would we make this as an equation? I probably should have put these guys here, but that's fine. If I wanted to make an equation of this, I'm going to simply do something that's similar to our parabola. We have x minus 3, y squared, plus y minus 1, y squared. And that is going to equal, space here, and that is going to equal our radius squared, obviously 5 squared, but and that is pretty much what we're going to create. So now what we know is that we have this x minus the horizontal shift plus y minus the vertical shift squared. And that will equal our square. So in this next problem, we have a circle with a center 2, comma 7, and a radius of 1. So again, that's a horizontal shift of 2, a vertical shift of 7. So we get x minus 2 y squared plus y minus 7 y squared. And that equals 1 squared. And we're done. And now for this one, where we have a circle where endpoints are at 5, comma 0 and negative 5, comma 0, remember the center of that circle is between those 2 points, which means the center here is at 0, comma 0. So if I wanted to create a equation for this one, it's actually a very nice equation. It's normal x plus y squared equals 25. Because these have a radius of 5 because they're not away from the center. You could have also done x minus 0 quantity squared, but that just seems like a tedious task. And lastly, how to read the graph in a simplified points. I have x minus 3, y minus 3, x plus y minus 3. And then my radius is going to be from 3 to 1. This is 1, so 2 units wide, so it's which we can just say. And then the last one, we're going to, we went to the left 2, so it's x plus 2. And then we went up 1, so it's plus y minus squared. And it looks like we went over 3 units of the radius, so we're 3 squared. And just in case you missed it,